Hello, this is Ms. DB, and in this video we're going to go over how to do Chapter 5, Section 7, which is on the Pythagorean Theorem, but a little bit more to it than the Pythagorean Theorem, just a squared plus b squared equals c squared. So make sure you have read over page 348 to 352. There's a lot of information in your text, a lot of examples, so don't skip that part. Alright, so we all know Pythagorean Theorem is a squared plus b squared equals c squared. We're going to use it in various ways. We're going to use it to find a side length, not always the hypotenuse, and we'll also use it when there's variables involved. So we'll set up an equation and use algebra to solve. So there's a couple examples up here of both of those kinds. Also, we're going to give our answers in simplest radical form, like this. We're not going to change these to decimals unless it says round to the nearest, 2 decimal places. So let's look at these are all pretty straightforward, except number 4 is a little bit different. But let's do one of these kind of regular kind of ones. Let's do number 2. No, 2 is the hypotenuse. Let's do number 3. So in number 3, they ask us to find a leg. So you're still going to write a squared plus b squared equals c squared. But we're not looking for c in this one. We know that c is 8 because the hypotenuse is always opposite of the right angle. You can call either one of these a or b, it doesn't matter. I'll just write x squared plus 5 squared. So then the next step is to go through and do the exponents. 5 squared is 25, 8 squared is 64, and then we'll subtract the 25 from both sides. Well, this one might be a perfect square. Nope, it's not. Okay, so 14 minus 5 is 9. And 5 minus 2 is 3. So we're going to take the square root of both sides, and that means that x is equal to the square root of 39. Now this one can't be simplified anymore. You can try, you can say, well, I know that 3 times 13 is equal to 39, but both of those are prime numbers and neither are perfect squares. So that one can't be simplified anymore. But let me just do an example of if you have the square root of, say, let's say 24. That one comes up quite a bit. If you have to simplify the square root of 24, you want to find the factors of 24 so that one of them is a perfect square. So 2 is not a perfect square, 12 is not a perfect square, 3 is not a perfect square, 8 is not a perfect square, but 4 is a perfect square. So I'm going to rewrite this as 4 times 6. And then the properties of square roots say that I can then write this as the square root of 4 times the square root of 6. And what is the square root of 4? The square root of 4 is 2. So now we have 2 times the square root of 6. Now it's been simplified. 6 does have factors. 6 is equal to 2 times 3, but neither of those are a perfect square. They're both prime, so that can't be simplified anymore. So if you ended up with the square root of 24, this is how you would simplify that. All right, let's look a little bit at number 4 as well. In number 4, the hypotenuse is x plus 1. So when you put your hypotenuse in here, you're going to have x plus 1 squared. And x plus 1 squared is not x squared plus 1. You have to FOIL that. We're going to list it out twice. I'm trying to erase that, but it's not letting me. There we go. Okay, so to FOIL, I usually actually write both of these factors 2 times. This is some review of algebra here. I'll go ahead and write 81 there. So you're going to go first times the first term. X times x is x squared. And then you take the outer term, which is x times 1. And the inner term, that's what the I stands for, inner times inner. And then the last times the last would be 1 times 1 is 1. And then you combine your like terms, which are usually the 2 middle terms, the outer plus the inner. And we get that. So that is what's on the other side. So now we have the equation x squared plus 81, sorry. Let me get a little more room here. Oops. There went my my equation left with it. That's all right. So now we have x squared plus 81 equals x squared plus 2x plus 1. Now this looks really complicated, like we're going to have to do a lot of work, but we can now subtract the x squared from both sides, and x squared minus x squared is 0, so we're just left with 81 here, and x squared minus x squared is 0 here as well, so we're just left with 81 equals 2x plus 1. And then you can finish solving that equation, subtract 1, divide by 2, and you'll get a value for x. And your directions were to find x, so there you go. Remember to simplify. Oh, you won't have a square root in that one, so it'll just be a straight value. And then here's an application problem that's very similar to the example. You're going to set up the Pythagorean theorem, put the right parts where they belong. In this one, they ask you to round to the nearest inch. So if you get an answer like 100, let me check what that is quick. They had 100 divided by 17, which is 5.888, and then they took the square root of that, and they got 2.4253. 2.4253. But that's not what they wrote for 2 feet 5 inches. It looks different, right? So to change, this is in feet. To change this to inches, we know it's 2 feet something. You need to change this part to inches. So let me get back to my calculator. To do that, you take the fractional part, which is just the decimal part there, the 0.4253, and multiply it by how many inches are in a foot. And it's 5 inches. That's the part that they used for the 5 inches. So if you get a decimal part, you take the decimal part, 0.4253, and multiply by 12, because there's 12 inches in a foot. That changes that part of your problem to inches. You would leave the 2 feet because that is in feet, and then the 5 inches goes over here. You'll have to do something like that on this problem as well. In this one, we're trying to figure out the length of, it says that the ratio of the slide must be in a ratio of 3 to 5. So this has to be 3 feet, this has to be 5 feet, or this could be 6 and this could be 10. It has to be in that ratio. So they already wrote the 3x here and the 5x here. So what you need to do is find the height. If the slide is about 8 feet long, what are the height, I think there's a height there. What are the height of the slide and the length of the slide? So you have to find this side and this side. And you'll do that by 3x squared plus 5x squared equals 8 squared. And solve for x, and then change it to the nearest inch. If you have 3 non-zero whole numbers, such that a squared plus b squared equals c squared, you call that a Pythagorean triple. This is a famous one, the 3, 4, 5, but there's other ones as well. So if all of your sides end up being a whole number, then you call it a Pythagorean triple. You can check by plugging it into the Pythagorean theorem. So on these two problems, you're just going to find the missing side, call it x or c or whatever you want, and then see if it's a Pythagorean triple. It'll only be a Pythagorean triple if you have whole numbers for all of your side lengths, including the one you just found. This is the Pythagorean Inequalities theorem. This may be new. You have to have the c squared on the left side to do this. So if c squared is greater than a squared plus b squared, then you have an obtuse triangle. If c squared is less than a squared plus b squared, then it's acute. If c squared is not on the left, then this is reversed. So keep c squared on the left, because then this will all work. So here's the rules for a right triangle, an obtuse triangle, and an acute triangle. And then for these ones, you're going to do that and see what kind of triangle you end up with. So if c squared has to be on the left, then take your biggest one, like in number 5, we'll do the 20 squared, and then we're going to see if it's equal, less than, or greater than 5 squared plus 14 squared. So you want c squared, and then you want to use either equal, less than, or greater than, depending on what you find, and a squared plus b squared. So 20 squared is 400, 5 squared is 25, 14 squared is 196, and I can see that 400 is going to be greater than whatever 196 plus 25 is. So this is obtuse, number 12. So make sure you keep the c squared on the left and then combine the other two to see what you get. And now on these two problems, you have to be careful of what these are multi-step. There's more than one step here. So here they want us to find length A. Here's A. Oh, they want us to find X. So here's X, but first we're going to have to figure out, okay, this is 25, but I don't know that this is 13 and this is 12, or this is 12.5 and this is 12. We don't know. There's not enough information. So I just called the base of this triangle A, which would make this one then be 25 minus A. So the first thing you have to do is use the Pythagorean theorem to find A. Once you find A in simplest radical form, then you can take 25 minus A in order to figure out what this side length is. So if A is 10, then you can take 25 minus 10 and you'll know what this side is. And then you do the Pythagorean theorem again in order to find X. Then it would be 9 squared plus whatever you get squared equals X squared. And in this one it's similar, except this time the whole base is X. So we need to find, we can call this A again, or you can call it something else, but we need to find this first. Then we can find the other one with the Pythagorean theorem, let's call it B, and then we can add those two together to find the length of X. So use the Pythagorean theorem 2 times and then find the sum of those two sides. And then there's just one more to check and see if Jelani solved this problem correctly. All right, let me know if you get stuck on anything. Have a wonderful day.